Let's see. All right, guys, questions on the homework? Question on any of the homework assignments before we get started? Now, there is one problem I do want to look at. It was problem number 26. The set of all real numbers greater than 19. I think, yeah, you're thinking of 27. And less than 32. So this here, the set of all real numbers greater than 19 and less than 32. So there's two things we need for set builder notation, because it asks us to write in set builder notation. It's our group of numbers, what numbers we're talking about. So we're talking about the real numbers. And then our description, greater than 19 and less than 32. Now we need to rewrite greater than 19 and less than 32 as an inequality. So yes, we will have our brace x bar for our set of all real numbers. Now the description, how we're describing it, are greater than 19 and less than 32. That means all the numbers that we can have are going to be between 19 and 32. Since it doesn't say greater than or equal to or less than or equal to, it means that we won't have 19 and 32. So 19 is less than x is less than 32. Even though it does say greater than 19, less than 32, we still have these kind of less than symbols. 19 is less than x, so all the numbers are going to be bigger than 19, less than 32. So we'd have 19 is less than x is less than 32. Does that make sense? And the reason I'm pointing this out is as I was looking through some of them, some of y'all were giving these here. We can't have this arrows, especially in a compound inequality, going in opposite directions. Because 19 is less than x is greater than 32 isn't quite saying the same thing. Also, when we have these inequalities, we need the arrows, the way they're opening, be opening to the right. Because we're saying that the numbers are going to be bigger that direction. And what I'm meaning is that we can't have the arrows pointing in this direction. Okay? Put these on my desk. If before the end of the hour, if you guys want to fix that or look back at it and make sure you got that one right, you can. But what we're looking at today is transformations, mainly describing the transformation or saying how the function was transformed. Now, when we talk about transformations, we're talking about how we move it up, down, left, right, stretch, shrink, reflection. What are we doing to the function? And each of these functions has a main parent, a starting function, one that they're all going to look similar to, that we're going to apply transformations to make them into a different function. Now, there's more than 4 families of functions. There's lots of different ones. But the 4 that we're going to look at today, mainly 3 of these, is constant, linear, absolute value, and quadratic. A constant function is just a straight line, flat line. It doesn't go up, it doesn't go down. It's just a number. And that's what we're going to call a constant function. And y equals 1 is the parent function of all constant functions. Now, constant functions aren't that interesting because all we can do is move it up or move it down. Because y equals 1 is the main parent function. We move it up 1, now it's y equals 2, y equals 3. There's not a whole lot that happens with it, so we don't really talk about it too much. Linear function. Linear function is the equation of a line. It's just a linear function, line. Now we can stretch it, shrink it, we can apply different functions to it. Our third one's our absolute value function. The way that we really identify the absolute value function is the V, our V-shaped functions. And quadratics are our U-shaped functions. We will spend a good bit of time on quadratics after this chapter. Chapter 2 and Chapter 3 are going over quadratics. There's a lot of stuff we can do with a quadratic, this U-shape, this parabola. Bless you. Domains are all real numbers. What that means, domain is our input values, our independent variable, the one that we change, the one that we plug in for x. Our range is our y values, the values that come out of the function. And the only one that's going to be all real numbers, we can plug any number in, get any number out, is going to be a line. Our absolute value in quadratics, there's only certain values that we can have. Now, there are several different types of transformations. Linear, quadratic, and absolute. These are the main three we're going to focus on because constant really doesn't tell us a whole lot. And I'll write this out here in a second. But when we look at any of these here, the general form, y is equal to a times x minus h plus k. This is the general form for the most part. We can add b in front of x, but this is the main one we'll be looking at here for a linear function. These three here are the general forms. And the reason I call them the general forms is because looking at each of these spots for a, h, and k will tell us what kind of transformation is being applied to the type of function, be it linear, quadratic, absolute value, or absolute value equations, these functions. Because if there's a value in place of a or a sign in place of a, we can tell what transformation is being applied to it. If there's a value for h, where h is, we'll be able to tell what transformation that is, and the same for k. Being able to see these spots will tell us what kind of transformation is being applied to the function. And knowing the general or the parent function and the transformation will tell us how the new graph should look, what should be happening to it. Now in here, for the most part, I am not going to spend too much time on graphing, straight graphing these functions. But I do feel it's important for us to know or get a picture of how it should look, what it should be happening to it. And we will be coming back to this slide and adding to it, especially when we start talking about what each of these letters is being represented by, what we know or what information each number in their corresponding spot is telling us. Now the first transformation we're looking at is going to be a translation. We're going to be talking about vertical and horizontal translation. Vertical, up and down. We're talking about moving the function up or down. Or horizontal, we're going to move it left or right. Because a transformation changes the size, shape, position, or orientation of a graph. A translation is a translation that shifts the graph horizontally and or vertically, but does not change its size, shape, or orientation. So literally, translation means I'm going to take it, and we're just going to move it up, down, left, or right. We're just moving it across the page. And it's going to change the points on the graph, but it's not going to change its shape. So if we had a absolute value, it's still going to have the same overall shape. All we're doing is either moving it up, down, left, or right. There is no change. We're not making it skinnier. We're not widening it out. We're not flipping it. We're just moving it up, down, left, or right. Now for us here, our vertical translation up or down is our K. K, vertical translation up or down. Whatever goes in place of K tells us how far we're moving it up or down. And that applies to all three. So our vertical translation up or down is going to be K. So whatever value goes in that place of K, and if you notice K is being added to outside parentheses, outside the absolute value, is going to tell us how far the function is moving up or down. Okay. Now we also have the horizontal translation, which is our left or right. And that is our H. That is the value inside the parentheses. That tells us how far the function is moving to the left or right. And with horizontal translation, it's going to be the opposite of what we think. It's going to be the opposite of how it looks, because inside our equations, it's x minus h. It's going to look the opposite. And we'll see that when we talk about it here in a second. It will show up, and I will be able to point that out and show you why it is that way. So vertical translation, up, down, is our k value. It tells us how far it's going up, or how far we're moving it down. H is left and right. It tells us how far we're going to move it to the left or to the right. So let's actually see two of these here with this horizontal and vertical. So the graph, g of x equals x minus 4. We want to identify the parent function and describe how far it moves. So when we look at this here, x minus 4 is our function. Now we need to determine if it's constant, linear, quadratic, or absolute value. Constant's already thrown out because it does have a variable x. Constant's just a number, a flat line. So there's its parent function, the one that it's coming from, can either be linear, quadratic, or absolute value. Which one do we think it is? Because there's a chance, if it is absolute value, we need what? Absolute value marks. We have absolute value marks. Because x plus 1, yes. For x minus 4? What? X minus 4. Do we have absolute value marks with this? No. So it's not absolute value. Quadratic, we're going to need parentheses and a square, yes? Or just x squared. We don't have that, so this has to be what? Linear. This will be a linear function. It is an equation of a line. And so what that tells us is that we're not graphing this, and I'm not going to make you graph it. This here is its parent function. So I just drew that in. This here is its parent function. Equation of a line. Goes through the origin, increasing, has a slope of 1. This is the parent function. Now the only value that we have, because if we look at it, we don't have anything being multiplied in front of the x. We don't have an a value. Do we have parentheses? No. So there is no value for h because h has to be inside parentheses. The only spot that this lines up with it in the general form of our a times x minus h plus k, no value of h, the only value is k. K is the only spot where we have a value. Now, according to what we've said so far, k represents what? Up or down. So what that's telling us is that it's moving the function either up or down a certain amount. What is the number in place of k? 4. So it's telling us it's going to move the function up or down 4 units. Every y value is going to either increase by 4 or decrease by 4. And for this here, determine if we go up or down is based off the sign. Is 4 positive or negative? Negative, it's going to be going down. So what this tells us is two things. One, it is a linear function. Equation of a line. So we know the parent function, as I drew it there, is what we have, yes? And we said we took every point on that function and moved it where? Down 4. So our new graph should be here. And again, I'm not going to make you graph these, but it's good to have an understanding of what's happening, what's going on with this function. Minus 4. Because that minus 4 took the place of k. It's not h, because h has to be inside parentheses or inside the absolute value. So it's down 4. Now, I haven't got the graphing calculators out yet. We will work through those and work with those throughout the semester. And I would, especially if we start doing graphing and stuff with it, making sure to get those and follow along. And, actually zoom, reset that. I need to turn that off. So this here is the parent function, y equals x. F of x equals x. That's our parent function. Now, the new function we said was x minus 4, yes? So it should be down 4, which is exactly what we said. Y'all see how this works. Let's look at the next one. G of x equals the absolute value of x plus 1. So we need to identify the parent function. What group is it with? It is. It's an absolute value. And kind of the giveaway that it's an absolute value is it has absolute value bars, yes? Now I'm going to write the general form above it. A parentheses x minus h plus k. Now, in the last one, we had a value for k, yes? This one here, is there a number where k is? No. Technically, there is. It's 0. But if it's not moving it up, it's not moving it down, we're not going to talk about it. Because we're actually talking about transformation we're applying to that is actually causing a change in the function. So what that's telling me, since there is no k here, it means that the function is not moving up and it's not moving down. We're not moving it up or down. But we do have a value in place of what? H. H is telling us it's either moving to the left or to the right. Yes? Now, how far are we moving to the left or to the right? 1. So we're moving 1 unit. Which direction do we think we're moving? Because it's positive, so we should be moving to the right. Now, the nice thing is we do have this graphing calculator, and it will let us do absolute value equations. Because as we can see here, we do have the absolute value of x. Yes? Our new one is the absolute value of x plus 1, yes? And this should move everything 1 unit to the, and it does, the blue to the red, we're moving 1 unit to the right, yes? No, what did it do? It actually moved 1 unit to the left. Okay. Well, let's look back at the general form. The general form inside the absolute value is what? X minus h, yes? The equation we have is what? X plus 1. Now, to make it match the general form, to make these be the same, these two here be the same, well, the only way that we can actually get it back to x minus h is if the value of h is negative. Because since it's plus, a negative and negative will make a positive. Because the general form is x minus h. And the only way we can change from x minus h to x plus 1 is if our value of h is negative. Okay? The way I remember it, left and right is always opposite of what we think. Because if we have x plus 1 inside the parentheses, it feels like we should be going to the right, but we're actually going to go to the left. If it had been x minus 1, we're not going to the left, we're going to the right. Left and right, inside those are the opposite of what we think, because it feels like it should be going to the right, but it's actually going to the left. Left and right, opposite of what we think. Anytime we have something inside those parentheses or absolute values, it's going to be the opposite direction. We're not going to talk about it in 1.2, but 1.3, we will talk about horizontal stretch or shrink, and it's still the opposite of what we think. Because it's going to look like a stretch and it's going to be a shrink. It's going to look like a shrink and it's going to be a stretch. Questions on up, down, left, right? We good with these here? Now the next type of transformation we have is reflection. A reflection is a transformation that flips a graph over a line called the line of reflection. A reflected point is the same distance from the line of reflection as the original point, but on the opposite side of the line. So if it's on one side, it's now on the other. Now the main one we'll have here is reflection across the x-axis. Reflection across the x-axis. And the way that we know we have one is if A is negative. If the value in place of A, outside those parentheses, outside those absolute value bars, if the value of that is negative, it's a reflection across the x-axis. We're not talking about the number itself. We're talking about its sign. If that number is negative, it's a reflection across the x. So we're talking about the sign of A. If it's negative, if there's a negative outside those parentheses, outside those absolute value bars, it's a reflection across the x. Now a good question is there a reflection across the y-axis? And there is. We're not going to really look at it today, but it's going to be inside those absolute value bars, inside those parentheses, in front of the x. So we call it B, but it's really going to be inside those absolute value bars, inside the parentheses. If it's inside, in front of that variable, it's across the y. This does not tell us a whole lot for especially quadratics and absolute value, because it's going to mirror onto itself. because the absolute value of x absolute, or in our quadratic, our x squared are symmetric to the y-axis. So just having this here is not changing anything. A is negative because we're across the x-axis. If the negative is inside the parentheses. And when we talk about this in 1.3, I add a letter to this, a b value in front of the x. I'm not putting it in yet just because there is enough. We have a, h, and k at this point. Throwing a fourth one that we're not going to talk about is a little much at this point. But if we look at this here, graph p of x equals negative x squared and its parent function, we want to determine what the parent function is for this negative x squared. Well, if we look at our three main types, which one has a square? Quadratic, it is a quadratic function. And what that's telling us, and what that should tell us, is if I'm thinking of a quadratic, its main parent function is going to be this U-shaped graph. It's not exact. What I just drew is not exact, but this should be the picture we get. Because when we think of a quadratic, it's a U-shaped graph. This is the parent, y equals x squared. Now that negative in front of the x squared, is that negative inside parentheses? Are there parentheses at all? No, unless we write the parentheses, they are not there. That is outside. That negative is where a is, yes? The a value specifically is 1. We're not caring about the 1 at this point. We do see that it is negative. Since it's negative, it's telling us there is a reflection across the x-axis. So if we're reflecting it across the x, right now it's going where? Up. So if we reflect it across the x-axis, it's going to go down. So that means our new function should open down. This quadratic's transformation is a reflection across the x-axis, because we're just seeing how did it change from the parent function. Because our parent function is f of x equals x squared, just x squared. We applied something to a, we changed the value of a from positive to negative. It's now negative a, which means it reflected across the x-axis. So instead of opening up, it's going to open down. X squared. Negative x squared. So the blue one's our parent function, our x squared. It's opening up. Our negative x squared did indeed open down. We reflected it across that line. We reflected it across the x-axis, giving us our new function. Questions on this here? Questions on anything we've done so far? All right, let's look at the next one. K of x equals negative x. What's our parent function? No, I think you had it at first, because what were we going to say before constant? Linear. We have x by itself, yes? So it is linear. Now, if it was a constant, we would say k of x equals negative 1. Because constant doesn't have the variable x at all. It's just a number. So this would indeed be linear. Now the general form, we'll call it f of x, a times x minus h plus k. There are no parentheses, so that means we do not have any value of h, nothing inside, it's just x. Do we have any number added to the end? No, so that's not telling us, so it's telling us it's not moving up, down, left, or right. We don't have any transformation there. The only thing we have is a negative in place of a, yes? Well, if A is negative, it has to be what? Reflected across the x-axis. Reflection across the x-axis. And again, I'm going to just rough visualize or show you this here. So if we have this here, we're reflecting across this x-axis. The x-axis. That means all of these points here are going to be reflected down here. It also means all the points here are going to be where? Reflected up there. Because we're essentially just flipping it across that line. Since the parent was increasing from left to right, its reflection should now be decreasing. Because there's our parent function, negative x graph. We can see it did flip across that line. It was going up, it's now going down. Questions on this so far? All right. Let's look at these next 5. These 3 here, and then the next 2. Let's look at number 2. G of x equals x plus 3. We first need to identify what group, what is its parent function. Linear, quadratic, absolute value. It is indeed linear. Because this is corresponding to our a times x minus h plus k. Now, for the most part with linear, we're really not going to talk about a left-right movement. There's not going to be a whole lot of reason to leave it x minus h. We're just going to have it essentially like we have here. X plus 3. That plus 3 is changing because the normal linear function, g of x, y equals x. We've added 3 to it. Yes? That plus 3, is it inside parentheses or outside? Outside. Since it's outside, it has to be going where? Up or down. And the amount we're moving up or down is 3, yes? Now, which direction are we going, up or down? Up, because the 3 is positive. That's it. That's all we're looking for. We added 3 to our parent function, that y equals x, f of x equals x. So it's moving it up 3. Number 3, f of x equals parentheses x minus 2, close parentheses, squared. Linear, quadratic, absolute value. Quadratic is a quadratic function, and we know because of the square. Now the general form, a parentheses x minus h squared plus k. The parent is just x squared. X squared would be the parent function. Do we have a value for k? No, it's 0. We don't concerned about that. Do we have a value for h? And it is 2. So since we do have a value for h, it is telling us that it's going to move it to the left or to the right. Because it is the opposite of what we think. So it's actually moving it to the right. And again, if we look at it, I'm going to get a highlighter out. According to the general form, the x and x inside the parentheses do line up, yes? Let's look at the signs. Minus and minus. So that tells us that h and the 2 will line up specifically. So our value of h is 2, yes? Specifically, it's positive 2, which positive is to the right, 2. But because it does have that minus inside, it makes it look negative, but it actually is positive. That's why we get that opposite direction. X minus 2, it looks like it should be left 2, but it's actually to the right 2, because the value of h is positive. Now the question that normally comes in is, but why is k not that way? But if we look at k, we have plus k, yes? Well, if I add a negative, we don't say plus negative 3, we just say minus 3, yes? The same thing with plus positive 2. We don't say plus positive 2, we just say plus 2. So up and down is exactly what it looks like. Inside the parentheses, we're not going to leave it as x minus negative 2. We're just going to say x plus 2. So again, that minus in the middle is getting it mixed up. That's why in here, instead of it being left 2, it's right 2. N of x equals a negative absolute value of x. Well, this here, its parent function is what? Absolute value. Kind of gives it away. Absolute value. A times absolute value of x minus h plus k. Do we have a number added outside of the parentheses? No, so that tells us what? We do not have up or. Do we have anything being added to the x inside the absolute values? No, so it tells us it's not moving to the left or to the right. The only thing that's different from the parent function is that negative in front of the parentheses, in front of the absolute value, not parentheses. Well, the only place that we have anything with a negative is a reflection. So it'd be a reflection across the x. Now, I will point out that it's talking nothing about the value of a. It's just saying, is it positive or is it negative? If it's negative, it's a reflection across x. Doesn't matter what the number is it negative? Since this is negative, we have a reflection across the x axis. Since it's negative, we have a reflection across the x-axis. The value that goes into place of a is going to be our vertical stretch or shrink, not the sign. The sign is purely attached to reflection. The value that's going in front of those parentheses, those absolute value bars in front of x, is our vertical stretch or vertical shrink. Questions on any of this so far? The last type of transformation, we're just going to talk about this. We're not going to hit a problem with this yet. Stretches or shrinks the function if a is greater than 1. If the number in front in that a spot is greater than 1, it is a vertical stretch. If the value of a is between 0 and 1, it is a vertical shrink. This here, vertical stretch and shrink, we're specifically looking at the value of a, not its sign. If that value of a, if the number there is bigger than 1, 1.1, 2, 3, 15, it's a vertical stretch. If it's between 0 and 1, it's a vertical shrink. So 2 is greater than 1 to be a vertical stretch. Even if it is negative 2, it's still a vertical stretch because the negative is not attached to the vertical stretch or shrink. That negative, when that value of a is negative, we're specifically talking about the reflection. In that spot for a, if it's negative, it's a reflection. If we have a number besides 1, it's going to be stretch or shrink. The negative tells us reflection. The number tells us whether it's a stretch or shrink. All right.